We're going to look at the Wavelogbbox control loop routing possibilities. We could access it through this menu over here. Here you can see lots of inputs and outputs. All of these connections internally are done in software, so it gives us flexibility to route calculations through different kind of paths. What's important to see is that this is the main output, which is a piezo, and here we could have the input going to a couple different ways. I have a copy of all the routing paths. To change the paths, you have to modify these switches. Also, you have the capability of changing the error sign at the stage of the block diagram. So let's take a look at the whole system. If you use the RCHE as a complete system with our optics and the Wavelogbbox, you're going to have this by default. So you have a set point over here, a high voltage output over here, and the feedback comes over here using the phase detector and the pounder over Hall technique. However, if you want to use the Wavelogbbox all by yourself with your own optics in a different experiment, you could have different situations. Here, if you just want to send a voltage out to the high voltage stage, simply select this path here. You have a fixed point that you change with a knob, and this gets propagated all the way to the end. At the proportional coefficient, you put a value of 1 or something else that you might want to use. For integral and differential, you put it to 0, and that way you have a high voltage amplifier. For here, you have another situation where you have an input coming through the ADC1. It goes here through the PID controller again. You could put a proportional gain to a value of your choosing. I and D, you set that to 0. And this makes a high voltage amplifier. Now let's look at another circuit. Over here, this kind of resembles a op-amp in gain voltage follower mode or non-inverting gain mode circuit. So here's the ADC input. It goes through a feedback loop and it exits over here on the high voltage amplifier stage. You could use this to test the PID controller with various variables for the coefficients. Let's go over here to this other situation where you might want to use this as a PID controller all by itself. So here you set your set point. You have over here the feedback coming through ADC1. You choose for the error positive or negative. Here you use the PID controller coefficients and it goes out to the high voltage amplifier.